Okay, I said I was going to do the two mounting holes next, but I lied, changed my mind. What I'm going to do now is I'm going to start machining this profile on the bottom here of the base ring. So first thing I'm going to do is put these two holes in here. Cut these two 1/68 radius cuts, and I'm going to do that. I'm just going to bore two holes in there, 336 thousandths in diameter. It's pretty much just an aesthetic thing, so I want to bore it so it looks nice. So let's go ahead and do that. So let's center up on the part on the y-axis here. This whole profile, or this whole part is symmetric, so we can just center up on it, locate everything off the center. And we'll pick up this surface here for X. Alright, so these holes are 816 thousandths. Where are we at here? Oh. Alright, I'm going to pick up this surface instead. The dimensions, it's dimension from the parting line between the two parts. So let's do that instead. We can do it from the base, but then we have more math to do. These are just oops, wrong one. Pushing wrong buttons here. So I lost my center on the y-axis. So these holes are 816 thousandths down. Right there. And 3/4 of an inch apart, so that's 3/8 of an inch each direction. So one of them's right there. And what did I say? 336 thousandths in diameter, so let's pop a drilled hole through there first, rough it out. Here's a 5/16, that ought to do nicely. Clean out most of the material. Alright, one creates the other way now. I don't care about the finish on this because it's just a rough cut. I'm going to bore these holes to diameter to the 368. This is just to get as much material out as I can. the other way. Alright, let's do some boring. Run the bar out till it scratches the side of the drilled hole. And add a few thousandths to it. Take a trial cut. Alright, let's see where we're at on that. Let me grab a small hole gauge. Again, these are not meant to be used with calipers. Always got to break out the mics when you're using transfer tools like small hole gauges and telescoping gauges. Okay, we are at 336. Look at that. Got lucky. Took a little bit heavy of a trial cut on it. So that's the size. Normally I wouldn't try and get that close, but we got lucky. It's just a aesthetic cut anyway. It doesn't matter if it's within plus or minus 10 or 15 thousandths, that's fine. But we're good, so let's take another one. Just good clean living, that's all. thing we're going to do is, there are two radii on the bottom here. One of the radii, the big one, the 683, fits the radius on top of the receiver of the rifle. The other one, the smaller one, the 375 radius, is just a clearance. So we'll put those two in next. And we're going to use this tool since we're already set. We already know this tool is set at 336. We can crank it out and get our 375 and our 683 radius for those other two features. Alright, so we're at 336 diameter or 168 radius now, and I want to go out to 375 for this relief cut. So the difference is 375 minus 168, 207. So I have to crank out my boring bar 207 thousandths. It's 50, 100, 150, 200, and 7 thousandths. Okay, now this is for the 375 radius on the bottom here. Okay, so we got to move a little bit farther down. Right now we're 816 down from this surface. We got to move down 1.336. So 816 to 1.336. I'm going to make it 346. For now, we'll take a roughing cut and then we'll go back and take the last 10 off. There's a finishing cut. And that's not right. Oh, okay. I guess I mismeasured these holes. What are those holes anyway? If you're going to make a mistake, it's always good to make it on the lean side. Oh, they look right. They are right. Let me see here. What's going on? Okay, so I figured out what I did. Everything's good. I just needed to go, instead of going 207 on the boring head, I needed to go double that because the boring head, because this dial measures diameter, not radius. So I got to go another 207. So there's 50, 100, 150, 200, and 7 thousandths. So there is our 3/8 radius. Now we just take a little bit of material off. That looks better. Okay, now moving another 10 on the x-axis to the 1.336 mentioned, and then we'll power feed down to the finished cut. sounds like it's going to chatter. Let's take another cut down. Alright, pull the part away before I raise the tool up so it doesn't leave a trace or track, and do the other one. We'll do rough cut. And there's our finish cut. Okay, now we got to jump from a 3/8 radius out to a .683 radius. I think rather than do all that counting, I'll just do it. Show you another way to set a boring bar. Let's center the spindle over this surface, which is 1.06 down from the parting line. So let's set 1.06 on the x-axis, right there. Zero that out. Now, if we move over our radius, .683, right there, now all we have to do is advance the boring bar till it touches this surface. We don't have to do any counting. Less chances for error. So let's just do that. It's going to be a ways. I hope it reaches. Might have to go to a larger boring bar. Yeah, looks like it's going to make it. Grab a piece of paper here and just use that as a feeler. About there. Here's a little scratch, so there's our 683 radius. Let's lock it down. And the center of that radius is 1.674 from the parting surface. So we'll set at 1.684 for a roughing cut. We're not taking much metal off here. It'll hardly taking anything off, but actually, let's just take it off in one cut. It's not going to remove much at all. So 1.674. There we go. I'm going to slow this down a bit. It's so much larger. Alright, now actually, you know what? That might actually hit my stop. Let me just check that out first before I go blundering on through. Yes, it will hit the stop. Okay. Bummer. It looks like I might be able to move it far enough to miss. I hate moving the stop now that it's set up, but it's better than boring a hole in it. Okay, that'll clear. there. Alright. What this is doing is just creating little pads that the scope mounts will rest on top of the receiver on the rifle. Only about a 1/16 inch wide surface.